Hello friends, I am Dr. G.S. Shahane, Professor and Head, Department of Electronics, DBF Dayanand College of Arts and Science, Solapur. Friends, today we are going to discuss about operational amplifier, inverting amplifier. What is operational amplifier? Operational amplifier is a high gain direct coupled amplifier. It has two input terminals and one output terminal. Look at this symbol. So these are the two input terminals. Terminal with negative sign is called as inverting input terminal and terminal with positive sign is called as non-inverting input terminal. Basically, this circuit was designed to perform mathematical operations such as addition, subtraction, multiplication, division, integration, differentiation and so on in analog computers. So it was used to perform mathematical operations and hence it is called as operational amplifier. So if it has to perform these operations, what must be the characteristics of that ideal op-amp? Look at these characteristics. So it has infinite voltage gain. Gain is infinite so that even a smallest input signal can be amplified with the help of that amplifier. Second one is infinite bandwidth so that all frequency signals can be amplified by the same amount. Its input resistance must be infinite. Its output resistance must be 0. Its CMRR must be infinite. Similarly, it must have 0 offset voltage and all these properties must be independent of temperature. What about practical op-amp? Look at this IC. IC741 is a practical general purpose operational amplifier. It is a 8-pin IC. Pin number 1 and pin number 5 are for offset null. Pin number 2 is the inverting input terminal. Pin number 3 is the non-inverting input terminal. Pin number 4 is for negative power supply. Pin number 6 is your output terminal. Pin number 7 is positive supply and pin number 8 is not connected. So this is a practical operational amplifier. What are its specifications? Look at these specifications. Its voltage gain is about 2 lakh. Very high. Even a small input signal in microvolt can be amplified with the help of this op-amp. Its input resistance is also very high. It is in mega ohm. Its output resistance is of the order of 75 ohm or even less than that. Its CMRR is about 90 decibels. Similarly, there is a provision for offset balance and that in this IC there is temperature compensation. So if we look at these characteristics of practical op-amp, they are almost ideal characteristics and hence practical op-amp is considered as ideal op-amp. So due to these versatile properties, this op-amp has a number of applications. These applications are broadly classified into two groups, linear applications and non-linear applications. So linear applications include inverting amplifier, non-inverting amplifier, summing amplifier, adder, differential amplifier, subtractor, integrator, differentiator and so on. Similarly, non-linear applications include log amplifier, anti-log amplifier, precession rectifier, peak detectors, clippers, clamper, comparator, Smith triggers, multivibrator, etc. So let us discuss about inverting amplifier. Use of this op-amp as inverting amplifier. What is inverting amplifier? So in this case, there is amplification, but at the same time, there is phase inversion. That is, input signal and output signal are out of phase by 180 degrees. Look at the input and output waveforms. This is the applied AC input signal, small AC input signal, and this is the waveform of output. You will see that there is phase inversion. During positive half cycle, you will get negative half cycle, and during negative half cycle, you will get positive half cycle at the output. So that is, there is phase inversion. So magnitude is increased, but at the same time, there is 180 degree phase shift, and that's why it is called as inverting amplifier. Look at the circuit diagram of this inverting amplifier. In this case, non-inverting terminal is grounded. Non-inverting terminal is grounded and input signal is applied to inverting input terminal. So see, this terminal with negative sign is our inverting terminal. And two resistors are connected. Resistance RF, it is the feedback resistance connected between output and inverting input terminal, and this is resistance Ri, input resistance. So note that in operational amplifier, most of the applications depends upon these external components. How we connect and what is connected, that decides the application of op-amp. In case of inverting amplifier, we require two resistors, RF and Ri only. Now here we are assuming that this op-amp is ideal op-amp, and its two important characteristics. Which one? Its input resistance is very, very high, almost infinite. And second one is open loop gain of op-amp is also very high, almost infinite. So these two characteristics are very, very important. What is its effect? Since the input resistance of op-amp is very, very high, current flowing into the op-amp is nearly equal to 0. Look at this. Let us suppose that I1 is the current flowing through this resistance Ri, I2 is the current flowing through this resistance Rf, and some current will flow into the op-amp through this inverting input terminal. But the magnitude of this current, since the resistance of this op-amp is very, very high, current flowing into the op-amp is almost 0. It is negligible, can be considered as 0, and therefore we can say that this incoming current, if we consider this junction point, nodal point, incoming current I1 is equal to outgoing current out2. Almost all current goes to this feedback branch. Current flowing through this input terminal is nearly equal to 0. This is important concept. Secondly, the open loop gain of op-amp is very, very high, and therefore the differential input voltage between these two terminals, between inverting and non-inverting terminal, also is nearly equal to 0. This happens because of the negative feedback. See, if we apply positive voltage at the input, then it is given to inverting terminal, so it is inverted at the output, you will get negative voltage, and because of this negative voltage, large current flows through this resistance, and therefore what happens? This applied input voltage is dropped across this resistance Ri, and voltage between inverting terminal and non-inverting terminal becomes nearly equal to 0. So always remember that since the open loop gain of op-amp is very, very high, the differential input voltage between two terminals is nearly equal to 0. What is its effect? In this circuit, non-inverting terminal is grounded. The potential difference between these two terminals is also nearly equal to 0, and therefore the potential of inverting terminal also becomes equal to ground potential, that is 0. So the potential of this inverting terminal becomes equal to 0. But actually it is not grounded. It is not connected to ground, but still its potential is equal to ground potential, and hence this point is called as virtual ground. So in this circuit we can say that inverting terminal is at virtual ground. This is also important concept. Is it clear? Now let us see how this circuit works as a inverting amplifier. Let us analyze this circuit. I1 is the current flowing through this resistance Ri, I2 is the current flowing through this resistance Rf, and this is our junction point. Apply Kirchhoff's current law at this junction point. So that you will get I1 equal to I2. Incoming current is equal to outgoing current. We are assuming that current flowing into the op-amp is almost equal to 0. So you will get I1 is equal to I2. What is the magnitude of I1? How to find out the value of current? Ohm's law. Potential difference divided by resistance. So I1 is the current flowing through this Ri. So this I1 is equal to Phi, voltage at this point, minus voltage at this point, it is 0, virtual ground. So Phi minus 0 divided by Ri. So you will get first term Phi minus 0 divided by Ri, magnitude of I1. Similarly, what about I2? I2 is the current flowing through this feedback resistance. See the direction of current. So, magnitude of current I2, how to find out? Same Ohm's law. Potential difference across this resistance divided by that resistance. So, what is the potential difference? Voltage at this point is 0. 0 minus VO divided by RF. So, you will get second current 0 minus VO divided by RF. So, you will get Phi upon Ri is equal to minus VO divided by RF. Rearrange it. Pho divided by Phi is equal to minus RF divided by Ri. But Pho divided by Phi is nothing but gain of this circuit, gain of this amplifier. So it is represented by AV. So AV equal to minus RF divided by Ri. This negative sign indicates that there is phase inversion. Circuit is working as inverting amplifier, and the magnitude of that gain is given by this formula RF divided by Ri. So these two resistors decides the gain of this amplifier. Say for example, if RF equal to 10 kilo ohm and Ri equal to 2 kilo ohm, then gain is equal to minus RF divided by Ri, that is 10 divided by 2 is its magnitude is 5 with negative sign, so gain is minus 5. So beauty of this circuit is that just by selecting proper values of these two components, we can select the gain of this circuit. We can have any magnitude of gain. Circuit works as a inverting amplifier. Is it clear? Thank you.